For review question 1, solve the following equations. So before I start on this question, for solving of indices, I must always keep in mind that I must try to make the base on the left-hand side and the right-hand side the same so that I can compare their powers over here. So for part A, 7 to the power of 2x minus 1 times 49 to the power of x equals to 1 whole. So in this question, just a quick scan. What is the common base throughout these three terms over here? Okay, so 7 to the power of 2x minus 1. There is no simpler form for the base of this 7. I leave it. And 49, what can I change it to? 49, I can actually change it to a 7 to the power of 2. So that is 7 square. Don't forget, I still have a power x over there. And for 1 whole, how do I change to a base of 7? Why 7? Because taking a look at the base over on my left-hand side, they are all having a base of 7 here. So for 0 indices, keep in mind 7 to the power of 0 equals to 1. In fact, anything to the power of 0 will also be equals to 1 whole. Okay? Okay, so from here, I realized that, oh, great, I've actually changed all my base on the left-hand side and the right-hand side to become a base of 7. So now over here, I can continue simplifying it first. Okay, so this one will be just 7 to the power of 2x minus 1 times this over here. I will be using this law of a to the power of m bracket n, which gives me a to the power of m times n. Okay, this is one of the law in indices. So this one, it's 7 to the power of 2 times x, which is 2x. And that gives me 7 to the power of 0. Okay, so now I need to further simplify this left-hand side over here. So how do I combine these two indices together? I will use this law of a to the power of x times a to the power of y, which gives me a to the power of x plus y. Okay, so same thing, 7 to the power of 2x minus 1 plus adding the two powers up together. Because of the same base, I can just add the two powers up. All right, equals to 7 to the power of 0. So over here, now that I have both the base the same, I can just compare the powers on both sides. So 2x minus 1 plus 2x equals to 0. And this is just a linear equation for me to continue solving. 4x equals to, I'll bring this minus 1 over to become a plus 1. And x is equals to 1 over 4, 1/4. Okay, that's all for part A. And continuing for part B. Okay, so what part B says? Part B, it's 7 to the power of x minus 1 equals to 1 over 49 to the power of 3 over 2. Okay, so now I have a fraction involved. Okay, so for part B, let's try and make this fraction to a non-fraction form first. So same thing, 7 to the power of x minus 1. I'll leave it, okay, because the base, I cannot further simplify it anymore. Same thing. So for this 49, I can change it to a 7 to the power of 2. Whole thing to the power of 3 over 2. Okay, let's further simplify this right-hand side. What can I do to this 1 to the power of 7 over 2? How do I make it to a non-fraction form? So when I pull the denominator upwards, the power will become a negative form. All right. Likewise, if I pull a numerator downwards, the sign of the power will just change. Okay. So this 7 to the power of 2, I pull it up, it becomes 7 to the power of minus 2. Take note, it is the power that becomes a negative form, not the base that becomes a negative form. All right. And this one, 3 over 2 stays the same. So again, from here, this one, I'm using the same law as the previous one. A to the power of m times n give me a to the power of mn. All right, I will just multiply the powers together. Okay, so this one, 7x minus 1, 7 minus 2 times 3 over 2 gives me minus 3. All right, so again, I'm back to this part over here where my base is the same. I can compare my powers. So x minus 1 equals to minus 3. X equals to minus 3 plus 1, which gives me minus 2. So for this, x is equals to minus 2.